of getting started, let's start your Rust journey. There's a lot to learn, but every journey starts somewhere. In this chapter, we will discuss installing Rust on Linux, Mac OS, and Windows, writing a program that prints a hello world, um, using Cargo, Rust's package manager, and build a system. So we will make a program that prints hello world, and then we are going to use a Cargo, which is a build system and package manager in Rust. Yeah. So and then installation is the first step is to install Rust. We will download the Rust through Rustup, a command line tool for managing Rust versions and associated tools. So this is like a Rustup is a command line tool, CLI tool, and you will need an internet connection for the download. Note if you prefer not to use Rustup for some reason, please see other Rust installation methods page for more options. So Rustup here, okay. So there is another way to install Rust, not only this Rustup. Interesting. So the following steps: install the latest stable version of the Rust compiler. Rust's stability guarantees ensure that all the examples in the book that compile will continue to compile with newer Rust versions. So stability guarantees ensure that all examples in the book that compile will continue to compile with newer. Okay, so like the newer Rust versions, it can compile the examples in the book. Okay. Stability guarantees ensure that all the examples in the book that compile will continue to compile. Rust stability guarantees ensure that all the examples in the book that compile will continue to Rust stability guarantees ensure that all the examples in the book that compile to compile with newer Rust versions. Okay, so in the examples, like examples here, these so if I run this code here like this, and it will compile with a newer version. Always makes sense. Okay, that makes sense. So the output might differ slightly between versions because Rust often improves error messages and warnings. In other words, any newer stable version of Rust you install using these steps should work as expected with the content of this book. Any newer stable version of Rust you install using these steps should work as expected with the content of this book. Because Rust often improves error messages and warnings. In other words, any newer stable version. The upper is slightly different versions. Any newer stable version of Rust you install using these steps should work as expected with the content of this book. Okay, that makes sense. Command line notation. In this chapter and throughout the book, we will show some commands used in the terminal. Lines that you should enter in a terminal all start with dollars. You don't need to type in the dollar character. It's the command line prompt shown to indicate the start of each command. Lines that don't start with a dollars typically show the output show the output of the previous command. Additionally, PowerShell specific example will use rather than dollars. Installing Rust up on Linux and Mac OS. Okay, I'll pass it. Installing Rust up on Windows. Okay, I will pass it. And then troubleshooting here. So we can check if we install the Rust or not, and doing Rust compiler, and then version, checking it. And then this is like you should see the version number come in. So let's see, you should see the version number, commit hash, and commit date for the latest stable version that has been released in the following format. Okay, so if we do the Rust C version, then this will appear. This is like a version number here, and then this is a commit hash, and then this is the commit date for the latest stable version. If you see this information, you have installed the Rust successfully. If you don't see this information and you are on Windows, let's check out. Okay, so it's also some another problems and update. Okay, so here we can update the Rust update and Rust self uninstall. We can uninstall Rust in this way. How to uninstall Rust and Rust up? Makes sense. And then local documentation, Rust up doc. Makes sense. Hello world. So hello world. Now that you've installed Rust, let's write your first Rust program. It's traditional when learning a new language to write a little program that prints the text hello world to the screen. So we will do the same here. Note, this book assumes the basic familiarity with the command line. Rust makes no specific demands about your editing or tooling or where your code lives. So if you prefer to use an integrated development environment IDE instead of the command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check the IDE's documentation for details. Recently, the Rust team has been focusing on enabling great IDE support, and progress has been made rapidly on that front. Creating a project directory. You will start by making a directory to store your Rust code. Okay, so we're going to start making a directory to store our Rust code, and it doesn't matter to Rust where your code lives, but for the exercises and projects in this book, we suggest making a projects directory in your home directory and keeping all projects there. So okay, so open a terminal and enter the following commands to make a projects directory and a directory for the hello world. Project within the projects directory. So open a terminal and enter the following commands to make a project directory and a directory for the hello world. So make the project directory and then cd and then make directory hello world. So cd hello world. Writing and running a Rust program. Next, make a new source file and call it main.rs. Rust files always end with the .rs extension. If you are using more than one word in your file name, the convention is to use an underscore to separate them. For example, use hello world.rs rather than hello world.rs. So now open the main.rs file you just created and enter the code in listing 1-1. File name main.rs. So listing 1-1, a program that prints the hello world. Save the file and go back to your terminal window and blah blah blah. So this blah blah. Okay, so. And then this is how we run Rust C main.rs, meaning that I compile this in main.rs. So yeah, so hello world here. On Windows, enter the command. Okay, so Regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to the troubleshooting part of the installation section for ways to get help. If Hello World did print, congratulations! You've officially written a Rust program that makes you a Rust programmer. Welcome, that's cool. An anatomy of Rust program. Let's review this Hello World program in detail. Here's the first piece of the puzzle. These lines define a function named main. The main function is special. It is always the first code that runs in every executable Rust program. Here the first line declares a function named main that has no parameters and returns nothing. Okay, it doesn't return nothing. It returns nothing. No parameters. If there are parameters, they would go inside the parentheses. The function body is wrapped in braces. Rust requires curly brackets. This is called the curly brackets around all function bodies. It's good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. Note, if you want to stick to a standard style across Rust projects, you can use an automatic formatter tool called RustFMT to format your code on a particular style. More on RustFMT in Appendix D. The Rust team has included this tool with the standard Rust distribution, like Rust-C, so it should already be installed on your computer. Makes sense. The body of the main function holds the function body. Okay, so the body of the main function holds the following code. Okay, println hello world. This line does all the work in this little program. It prints text to the screen. There are four important details to notice here. First, the Rust style is to indent with 4 spaces and not a tab. Second, println calls the Rust macro. If it had called a function instead, it would be entered as println. So this is a macro, Rust macro. If it had called a function instead, it would be entered as println without the exclamation mark. We will discuss Rust macros in more detail in chapter 19. For now, you just need to know that using an exclamation mark means that you are calling a macro instead of a normal function, and then macro don't always follow the same rules as functions. Third, you see the hello world string. We pass the string as an argument to the println macro, and the string is printed to the screen. Fourth, we end the line with a semicolon, which indicates that this expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. Most lines of Rust code. Compiling and running are separate steps. You just run a newly created program. So let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the Rust C command and passing it the name of your source file like this. Rust-C main.rs. So before running a Rust program, you must compile it using the Rust compiler by entering Rust-C. So this is what it's not running the program, but it's compiling the program. It's compiling the source code, and then it will make the executable program, I guess. So if you have a C or C++ background, you will notice that this is similar to GCC or CLang. After compiling successfully, Rust outputs a binary executable. On Linux, Mac OS, and PowerShell on Windows, you can see the executable by entering the ls command in your shell. On Linux and Mac OS, you will see 2 files. Okay. using ls showing this executable file here main, and then with cmd on this you should enter the following. This shows the source code file with the .rx extension, the executable file main.exe on Windows, but main on all other platforms. And when using Windows, a file containing debugging information with the .pdb extension. From here, you run the main or main.exe file like this. So a file containing debugging information with the pdb debugging. Okay. So this file is containing debugging information. Okay. Oh. On Linux and Mac OS, we see the two files of window on Windows. We see the three files, including the PDB, which is a debugging. Interesting. Okay. So this shows the source code. Okay. So if your main.rs is your hello world program, the line print is hello world to your terminal. If you're more familiar with dynamic languages such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead of time compiled language. If you're more familiar with dynamic languages such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead of time compiled language, meaning you can compile a program and give you the executable to someone else, and they can run it even without having Rust installed. If you give someone a .rb, a .py, or a .js file, they need to have a Ruby, Python, or JavaScript implementation installed respectively. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. So if you are more familiar with a dynamic languages such as Ruby, Python, or JavaScript, you might not be used to compiling. Yes, for sure, because they are not compiler languages. And separate steps. Rust is an ahead of time compiled language, meaning you can compile a program and give the executable to someone else. So I mean ahead of time, meaning that I guess that it's like before the runtime, maybe. Yep. Compile the language, meaning you can compile a program. Yeah, so before running the program, we compile it. So it's ahead of time compiled the language, I guess. So and they can run it even without having Rust installed. If you give someone, okay, so you need Ruby and JavaScript installed respectively. Yeah, like an Node.js. So just compiling with Rust C is fine for simple programs, but as your project grows, you will want to manage all the options and makes it easy to share your code. Next, we'll introduce you to the Cargo tool, which will help you write real-world Rust programs. Okay, so for simple programs, just Rust C only this one is fine, but later, like as a project grows, there can be another options to compile the program, I guess. Okay, so hello cargo. So hello cargo. Cargo is a Rust's build system and package manager. Most Rustaceans use this tool to manage their Rust projects because cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. Cargo is Rust's build system and package manager. Cargo is Rust's build system. Package manager. Most Rustaceans use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. The simplest Rust programs like the one we've written so far don't have any dependencies. If we had built the Hello World project with the Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you will add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. So simplest Rust programs like the one we've written so far, Hello World program, don't have any dependencies. If we have built the Hello World project with Cargo, it only use the part of Cargo that handles building your code. Just part of code we're using the Cargo. As you write more complex Rust programs, you will need add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. Okay. So using Cargo will be much easier to add dependencies. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you install the Rust through some other means, check whether Cargo is installed by entering the following into your terminal: Cargo version, like a Rust version, Rust C version. If you see a version number, you have it. If you see an error such as command not found, look at the documentation for your method of installation to determine how to install Cargo separately. Creating a project with Cargo. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Navigate back to your project directory or wherever you decided to store your code. Then on any operating system, run the following. So creating a project with Cargo. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Navigate back to your project directory or wherever you decided to store your code. Then on any operating system, run the following. Cargo new, hello Cargo. Okay, so making new. Okay. The first command creates a new directory and project called hello underscore Cargo. New directory. Okay, so we've named our project hello underscore Cargo, and Cargo creates its files in the directory of the same time. Go into the hello underscore Cargo directory and list the files. You will see that Cargo has generated 2 files and 1 directory for us, cargo.toml, and src directory with a main.rs file inside. It has also initialized the new Git repository along with a .gitignore file. Git files won't be generated if you run Cargo new. Within an existing Git repository, you can override this behavior by using Cargo new vs git. Note: Git is a common version control system. You can charge Cargo new to use different. Okay, wait a second. So it has also installed a new Git repository along with .gitignore. Oh, so it creates the Cargo new creates a Git repository too. with a .git file. The Git files won't be generated if you run cargo new within existing Git repository. Oh, okay. So if I am using cargo new inside the Git repository, then it won't generate Git files. That makes sense. So it will just use the repository information, I guess, if the Git files there. And you can override this behavior by using cargo new VCS Git. You can override this behavior by using cargo new version control system Git. Oh, okay. So note the Git is a common version control system. You can change cargo new to use a different version control system or no version control system by using VSS flag. And cargo new help to see available options. Open cargo.toml in your text editor of choice. It should look similar to the code in listing 1-2 file name cargo.toml. So like this. Listing 1-2 contents of the cargo.toml is generated by cargo new. This file is in the toml. Tom sub is minimal language format, which is cargo's configuration format. Tom sub is minimal language. Interestingly. The first line package is a section heading that indicates that the following statements are configuring a package. So these are package section here. It indicates the following statements. The following statements are configuring a package. So this is a configuring package. As we add more information to this file, we will add other sections. The next 3 lines set the configuration information cargo needs to compile your program. Your name. Wait a second. The next 3 lines set the configuration information cargo needs to compile program. The name, the version, and the edition of Rust you use. We will talk about the edition key in Appendix E. The last line, dependencies, is the start of a section for you to list any of your project dependencies. The last line, dependencies, here is the start of a section you to list any of your project dependencies. In Rust, the package of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in chapter 2, so we will use this dependencies section then. Now open src main.rs and take a look. File name src main.rs. Cargo has generated the hello world program for you, just like the one we wrote in listing 1-1. So far, the differences between our project and project cargo generated the cargo placed the code in the src directory, and we have a cargo.toml configuration file in the top directory. We have a cargo.toml configuration file in the top directory. So wait a second. So far, the difference between our project and project cargo generated, or the project cargo generated, or that cargo placed the code in the src directory, and we have a cargo configuration file in the top directory. Okay, makes sense. So cargo expects your source files to live inside the src directory. To the top level project directory is just a readme files, license information, configuration files, and anything else not related to your code. Using cargo helps you organize your projects. There's a place for everything, and everything in its place. If you started a project that doesn't use cargo, as we did with the Hello World project, you can convert it to a project that does use cargo. Move the project code into the src directory and create an appropriate cargo.toml file, building and running a cargo project. Now let's look what's different when we build and run the Hello World program with cargo. From your Hello Cargo directory, build your project by entering the following command: cargo build, compiling Hello Cargo, blah 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 blah. So now let's look at what's different when we build and run the hello world program with cargo from your hello underscore cargo directory. Build your project by entering the following cargo build. So this command creates an executable file in target debug hello underscore cargo target debug hello dash underscore cargo or target debug hello underscore cargo.exe on Windows. Rather than in your current directory, you can run the executable with this command. If all goes well, hello world should print to the terminal. Running cargo build for the first time also causes cargo to create a new file at the top level. Running cargo build for the first time also causes cargo to create a new file at the top level. Cargo.log. This file keeps track of the exact version of dependencies in your project. This file keeps track of the next versions of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its content for you. We just built a project with a cargo build and ran with .cargo debug hello cargo. But we can also use a cargo run to compile the code and then run the resulting executable all in one command. Wait a second. So first hello cargo build for the first cargo.log if the file keeps track of the exact versions of dependency in your project. This project doesn't have the dependencies. The file tracks all the cargo.log tracks the exact version of dependencies in project. This project doesn't have a dependency, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its content for you. We just built a project with a cargo build and ran with a target debug cargo hello cargo. But we can also use a cargo run to compile the code and then run the resulting executables all in one command. We just built a project with a cargo build and ran it with a .target debug hello underscore cargo. But we can also use a cargo run to compile the code and then run the resulting executable all in one command. Makes sense. So using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary. So most developers use a cargo run. So using cargo run is more convenient than having to remember to run cargo build. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary. So most developers use a cargo run. Notice that this time we didn't see output indicating that cargo was compiling hello underscore cargo. Cargo figured out that the files hadn't changed it, so it didn't rebuild it, but just ran the binary. If you had modified your source code, cargo would have rebuilt the project before running it, and you would have seen this output. Compiling here, okay. So cargo also provides a command called cargo check. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. So cargo check quickly checks your code to make sure it compiles but doesn't produce an executable. Makes sense. Okay. So it means that it doesn't build the project, but just checks if the program is available to compile. I guess if there's no error or not. Cargo checking error. Okay. So why would you not want an executable often? Cargo check is much faster than cargo build because it skips the steps of producing an executable. If you are continually checking your working while writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many Rust sessions run a cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they are ready to use the executable. Let's recap what we've learned so far about cargo. We can create a project using cargo new. We can build a project using cargo build. We can build and run a project in one step using cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as our code, cargo stores in its target debug directory. Instead of saving the result of the build in the same directory as our code, cargo stores it in the target/debug directory. An additional advantage of using cargo is that the commands are the same, no matter which operating system you're working on. So at this point, we will no longer provide specific instructions for Linux and Mac OS versus Windows. So an additional advantage of using cargo is the commands are the same, no matter which operating system you're working on. That's cool. So at this point, we will no longer provide specific instructions for Linux and because it's the same. So building for release. When your project is finally ready for release, you can use a cargo build release to compile it with optimizations. This command will create an executable in target release instead of target debug. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. Turning them on lengthens the time it takes for your program to compile. So compile time increases when using release, okay, and because of optimization, okay. So this is why there are two different profiles, one for development. This is why there are two different profiles. One for development when you want to rebuild quickly and often, and another for building the final program you will give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you are benchmarking your code's running time, but be sure to run cargo build release and benchmark with the executable in the target release. Cargo as convention. With a simple project, this cargo doesn't provide a lot of value over just using rustc. With simple projects, cargo doesn't provide a lot of value over just using rustc. With simple projects, okay. So, but it will prove its worth as your programs become more intricate, with complex projects composed of multiple grades. It's much easier to let cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you will use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using Git. Change it to that project's directory and build. Even though Hello Cargo project is simple, it now uses much of the real tooling you will use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using Git. Changing the project directory and build. Git clone example, some project cargo build. Makes sense. For more information about cargo, check out its documentation. Summary. We were already off to a great start on your Rust journey. In this chapter, you will learn how to install the latest stable version of Rust using RustUp, update to a newer Rust version, open locally, install the documentation, write and run a Hello World program using Rust.C directly, create and run a new project using the doc conventions of Cargo. This is a great time to build a more substantial program to get used to reading and writing Rust code. So in chapter 2, we will build a guessing game program. If you would rather start by learning how common programming concept works in Rust, see chapter 3 and then return to chapter 2. So summary again, let's check again. Install the latest stable version of Rust using RustUp. Update on your version. Okay, Rust update. Open locally, install documented Rust doc, and write and run a hello world programming using Rust directly. Okay, create and run a new project using the conventions of Cargo. Yep, Cargo new and Cargo build, or Cargo run, or Cargo check, and Cargo build release will produce the optimized version. Yes. And about the Git repository, cargo new, if I do cargo new, then it will create a .git ignore and then git files for the Git repository. But if there is already existing Git repository that I create projects cargo by using cargo, then there won't be Git files, because it is going to use just the previous the existing Git repository information. So programming a guessing game. Okay. Quite long.